Can we display a clean-looking stocks dashboard in a Python web app? Hello data fans! Yet another financial analyst came to me with this Google Sheets live stocks dashboard. And yes, you can fetch live and historical stocks data in Google Sheets. I will show you later. This person wants to report insights through a web interface with a watch list of cards, an interactive widget to dig into a company's stock movements, and a table with 12 precision floating points for the hardcore number crunchers. Can we build that interactive dashboard with Streamlit, a Python library to quickly build interactive web apps? Well, I've been building internal tools and reports with Streamlit for 4 years now, and this was my original take on the problem. But the internet wants to convince me that this is as far as I go, because Streamlit is hard to customize visually. Well, you know what? Don't believe everything you read on the internet. You can push the design a little further with some HTML and CSS tricks. So grab a notebook, a pen, some popcorn, whatever, and enjoy this Streamlit speedrun jam-packed with information. Use your Gmail account to open a clean Google Sheets page. In the leftmost column, add stock ticker symbols from companies you follow. For each symbol, add a new sheet of paper and rename it to match the symbol name. We will download historical stocks prices per company in there later. Google manages its own financial market service for stock prices. It's called Google Finance. And since it's in the Google ecosystem, Google Sheets can download data from Google Finance in a cell using the Google Finance method. Run Google Finance with different input arguments on the ticker symbol column to get the company name, the latest stock price, or the volume of traded shares in new columns. I added a few more variables like market cap, change percentage, and last trade time. I have no clue what those are for, I just want a lot of columns. Yeah, don't use this work to make actual trading decisions. Then in each company sheet, download the daily historical open, close, high, and low stock prices for the past 2 years, also using the Google Finance method with a specific all attributes. If you're in a rush and don't want to build these Google Sheets yourself, I left a GitHub link in the description leading to an Excel file to re-import from. And there you can now share this datasheet to the email address of other business analysts through the share button. Or if you want to automate your job away, share it to a Python program that has a Google account so it reads it for you. You access Google Sheets by authenticating using your Gmail account. But your Python code is a silly little program that doesn't have an account, so it cannot connect to your data yet. And no, we're not going to let it use our own personal credentials. Head to the Google Cloud Platform console. This is your Google Cloud cockpit, where you authorize people and machines on a project to interact with Google APIs and services like Google Maps, Google Sheets, or text-to-speech.
Hello, data fans.
To get started, select an existing project or create a new one. First, search for the Google Sheets API. When you click on the first marketplace search results, Google prompts you to enable programmatic access to the Sheets API, which you shall gladly accept so Python can interact with Google Sheets through the API. Second, open the Service Accounts page. If you read the top of the page, it says,
a service account represents a Google Cloud Service identity, such as systems running outside Google.
Yep, that sounds like pseudo Gmail accounts to give to your Python application. Create a new service account with a meaningful name and description. Then, in the Account Access to the Project section, select the basic viewer role. With this viewer service account, your doofus Python code will have permission to view Google Sheets links you share to it, but no editing permission. Now, how can Python use this service account info to connect to your Google Sheets? Open the three dots menu next to your new service account. Click on Manage Keys and create a new key in JSON. This downloads a new file on your computer which contains the service account credentials Python can use to connect to Google Sheets. You can move it into your Python project folder. Be careful, this file is like a hard-coded email and password Gmail account. You don't want to broadcast it to the world for others to access the resources. So add it to your gitignore and don't push it on GitHub. Finally, back to the Service Accounts page, copy the email address for the account and share your Google Sheets to that email. Okay, I found a small Python sample to test the connection. Open a Python terminal, read the service account and query the stocks Google Sheets. That works, your dashboard is ready to be created. But, you know, this code sample is a little too low level for me. I hope we're able to find an easier way to download Sheets data into Python. Inside your favorite Python IDE, open a new Python file to host your script next to the JSON key service account. Create a new .streamlit folder with a config.toml file. Configure the rerun on save flag to have Streamlit rerun anytime you save the Python main script. It will make your life easier. In a command line terminal, pip install Streamlit, Pandas, Plotly, and Airbyte in your preferred Python virtual environment. Airbyte? What's Airbyte? Run the streamlit run app.py command in the terminal. Call sttitle with an attention-grabbing title, save the file, and the Streamlit script should rerun from top to bottom, greeting you with a new title. Change the title in the code and watch it rerun the scripts and reload your app. Isn't Streamlit rerun from top to bottom awesome for live coding? Now I need an easier way to download data from Google Sheets into my Pandas Dataframe using my service account. I could ask my data engineer, "Hey, Fanuli, what Python library would you use for this?" Airbyte, my friend, is a popular open source data integration library with over 250 data connectors. Download GitHub issues, Google Sheets, or the latest tweets and Instagram stories from your favorite YouTuber directly into Streamlit or Jupyter notebooks with the PyAirbyte Python client. No external Airbyte cloud platform nor account required. This makes it Every Airbyte connector has its own documentation for prerequisites to follow. Reading from the Google Sheets section, the Airbyte connector binds to the Google Sheets API using a service account. Well, isn't that unexpected that we have one already? So create a new function to read the service account file into your app. Remember, when you use Streamlit, you assume the script reruns from top to bottom on every file save. This is a core Streamlit mechanism. It makes it a breeze to live code a Python script as if you were rerunning the file every time you saved it. But it's not very useful to reread the service account file at the top of the script over and over and over again for each save and rerun. So to prevent multiple service account reads, add as stcache data on top of the method. The function's output, in this case the service account, is saved in Streamlit server-side cache and pulled at every rerun, instead of repeating a read from disk. We also don't want to rerun Airbyte Sheets download on every script rerun. Even if the Google Sheets API is free of charge and Airbyte is smart enough to not download data if it doesn't detect remote updates to pull. So split the database connection and the data download into two distinct functions. The Airbyte connection method gets a stcache resource decorator to save the resulting Airbyte connection as a global resource across multiple user sessions. And download data is decorated with stcache data, so each user session gets its dedicated Google Sheets data result stored in the Streamlit cache. There are ways to clear the Streamlit cache periodically with the TTL argument or programmatically with stclearCache. You will find instruction in the Streamlit documentation. Now, in the database connection, read the service account file and initialize a new Airbyte connection with it. The source Google Sheets ID of the data connector as well as the configuration of the connector are specified in the Google Sheets section of the PyAirbyte documentation. I really just copy-pasted the link to the Google Sheets into it, defined authentication to use the service account, and return the connection. If you were to run the app now, Streamlit would issue red warnings everywhere like I'm not able to hash the database connection. Call meets mine by prepending the connector variable with an underscore so Streamlit doesn't try to hash it. Airbyte connection successful and stored in Streamlit's server-side cache. Now are you ready to download Google Sheets data into your app? Each Airbyte data connector defines a number of data streams to pull data from. In the Google Sheets connector case, each sheet is pulled as a separate stream that you can then materialize into an up-to-date Pandas data frame with the toPandas method. For this project, configure the connection read to pull data from all Google Sheets streams. I'm not touching too much on data refreshers on this project, but it is possible to select and refresh the data from specific streams only. And you can even update with a particular strategy like upsert write or full refresh. On the first run, Airbyte will download the Google Sheets connector to an external virtual environment for you, then check the remote data source and manage downloaded data in an internal DuckDB cache. Then I pull the ticker stream as a pandas data frame using the toPandas method and build a dictionary where each symbol stream maps to its pandas historical data from the datasheet stream. Return those data frames and display them into your app with Dataframe to check whether the data was correctly downloaded. Thank you Airbyte for sponsoring. In a new display overview method, show the downloaded ticker sheet using the Dataframe method. What gives Streamlit an awesome developer experience is how its live top to bottom rerun lets you visualize the end result anytime you save your code updates. Using that, build a transform data method to process the overview data frame and pass it into display overview. This is where I convert the last trade time into a date time, edit all price columns into numeric columns, and extract the array of historical stock prices per symbol from the historical dictionary into the open column of the overview data frame. Back to the data frame display. Notice how the list of open stock prices at the end and the Airbyte metadata is not really interesting. Hide Airbyte metadata columns from the display with the column order argument. Wouldn't it be better to show an ARIA sparkline instead of that list of numbers? If you think so too, dear data fan, then configure the display of the open column by adding an ARIA chart column configuration pointing to the open column with the list of prices. Ta-da! Much better now. Also, Dataframe can display pandas dataframe with specific CSS styling of background and font color, with a few more methods to change the color of the change column to red if negative, green if positive, and coloring the background to gray for odd numbered rows. We get a pretty good looking table. That one was for you, finance number addicts. I know you financial analysts love tables full of numbers, but I can't. My short attention span needs colored plots and big KPI indicators. How about a section where the user selects a company with a time period and the app displays the company stock's movement and financial KPIs? Create and call a display symbol history between the title and display data frame. Split a row into 3 columns with different sizes. You add a widget to a column by replacing ST with the name of the column. So the first one gets a select box with the list of all company names, the second one gets a select box with a list of periods, and the third one gets nothing. Whenever you choose a company or a period in your app, the script will rerun from top to bottom, and the selected value is stored inside the return Python variable. Use the selected company and time period to fetch the related historical stocks data frame from the dictionary, and filter the data frame on the chosen time period by indexing and filtering over the date column. Now to find a modern financial chart, like this Candlestick. It is documented in my favorite interactive plotting library to use with Streamlit. I use Plotly everywhere. It has zooms, selections, and legend filters by default. Plus the documentation has so many code examples it's hard to beat, and ChatGPT is decent at generating Plotly code from a chart description. In a new plot Candlestick method, create 2 Plotly subplots sharing the same X date axis, with the top one being taller than the bottom one. Return the Plotly subplots figure and display it on the app using the stPlotly chart method. Hey, you're now free to edit the Plotly chart and see the updates in real time in the app. In the first row, draw a Plotly candlestick using the open, high, low, and close pandas series over the date index from the history data frame. In the second row, plot the volume of traded stocks over the x-axis dates. Update the layout to add some titles, style their size and color, a legend, and some internal CSS margins to control the chart's position inside the Plotly container. And there you have, it's a pretty good looking plot already. Now I like to see big aggregated metrics next to my graphs. Split a row into 2 columns. If you need to put multiple widgets inside the same column, I suggest, instead of replacing st.dot with the name of the column, to call them inside the column's context manager. Using the with context manager notation, display the previous plotly chart under the left column and edit the width of the left column until you are satisfied with the layout of information. Streamlit lets you nest columns into columns, so divide the right column into 2 more columns and display minimum and maximum values for stock and volume with stmetric. I took the liberty to add a st container after the 2 columns and display 2 more computed metrics inside this st container to get a, kind of a grid-like feel. This container has no usage right now, but trust me, it will become our savior later when we need to pimp out those 2 metrics. One last thing to remember, anytime you interact with the select box widget, the full app reruns from top to bottom. I feel like that's the 5th time I say this, but whatever. Since those widgets only affect Streamlit displays inside the same function, you might as well tell Streamlit to only rerun the function when you play with the widget and not the whole app. Well, developers have heard you, and one of the newest Streamlit features in version 1.33 is the fragment. Decorate the display overview method with st experimental fragment, and now every widget interaction inside this function only reruns this function and not the whole app. In the long run, whenever you sense parts of an app have limited numbers of widget dependencies, try to bundle them inside the same fragment method so they don't trigger a full rerun of a huge app with a lot of non-cached variables. So what's the container for? When you're browsing your Streamlit web app, press Ctrl-Shift-C or go through the browser menus to find the DevTools HTML inspector. This is your most important tool whenever you are manipulating front-end code because it shows the direct mapping between HTML CSS code and the Streamlit widgets you are hovering over. For example, hover over the Streamlit metric element and you will see the corresponding div data test ID equals stmetric tag. Just for fun, there is a CSS rules window next to the HTML inspections. With the stmetric block selected, add a background color red to edit the color of the metric in your browser. You just applied your first CSS rule to a Streamlit widget. Yeah. Streamlit CSS hacking is all about guessing the HTML tags generated by Streamlit functions, then target the HTML tag, apply CSS rules on it, and pray that this is the Streamlit widget you need. This is a very important skill to train, so I'll let you practice it by hovering over your app with the inspector. Go for it, go train. I'll be waiting. Now that you're a master at hovering HTML tags, inspect the container containing those 2 metrics. It materialized into this div data test ID st vertical block. Same thing with the nested columns, they appear as divs with st vertical block. Notice how elements you put inside containers and columns are embedded in their own st vertical block elements. While you cannot embed your custom CSS class into containers and columns yet, you can achieve a similar result by hiding an invisible span element with your custom CSS class at the top of the container. Add a low indicator span class to the left nested column, a high indicator span class to the right column, a bottom indicator span class to the bottom container, then visualize each HTML layout element to check the presence of the invisible span CSS classes. In a few minutes, I will show you how to use those invisible spans for a CSS glow up. But we have one last section to build. The company card with a company name, its stock price, and a small sparkline that looks amazing. I really want to imitate it. As usual, define a new section by creating and calling a display watchlist method. Let's first split the list of ticker rows from the data frame into batches of 4. Each batch of 4 ticker data will be displayed into a row of 4 columns. Python 3.12 provides a batched method in itotools to split a list into a list of tuples with 4 ticker symbols. If you don't have Python 3.12, you can still copy a rough equivalent from the documentation. Iterate through the batches. For each row of 4 companies, slice 4 new Streamlit columns, zip the row of data to the row of columns, and for each symbol in the row, display a watch list card. To build the card, I first create a container with a border, append an invisible span element of class watchlist card for future CSS purposes, then split it into 2 top columns and 2 bottom columns. And yes, each column gets its own invisible span class. Then add some info into each corner, like the company name in the top left, or the symbol and a colored text depending on the date change in the top right corner. Bottom left corner gets a label and price, and bottom right corner gets a plotly line chart where the layout has been updated so that all axes and legends are made invisible and margins are minimized as much as possible. This is a decent looking dashboard. I could actually ship this. But if it's not dazzling enough to get your data project noticed, it's time to inject CSS makeup to widgets through those invisible spans. Let's pimp up the stocks dashboard title first. Download the permanent marker font from Google Fonts and put it inside the static folder. Streamlit needs a specific configuration to deliver static assets from the static folder. Enable it by opening the Streamlit config.toml file and adding the enable static serving flag. Stop and restart the Streamlit server in your terminal, head over localhost app static permanent marker ttf, and you should find the font being delivered to the browser. Replace the st title with an h1html tag and the title CSS class. Create a new styles.html file in your folder with an empty styles tag and load it into your Streamlit app using the st.html method. This file controls all CSS to apply into the Streamlit app. Start by targeting the title tag with the CSS class title and turn it into a bright red color. Streamlit doesn't track the HTML file. It won't live reload automatically when you save it. You must refresh the page by pressing R in the browser to see the HTML code changes. Load the permanent marker font from the static folder at the top of the styles, then inject the font into the title. Make its font size a little bigger, and now you have a really attention-seeking title. Another easy element to target is this subheader. If you inspect it using the HTML inspector, you will find the text is located in a span 3 levels deep in an h3 div. You can target it by asking for all h3 to div to span elements, but this is a little too specific, and targeting any span element under an h3 tag should do the trick. Restyle it into bold green open sans, or sans serif if the font is not installed on the computer. In those 2 examples, you saw how to target a CSS class and select children elements inside this selection. Well, you're an expert now, so let's aim for a harder Streamlit widget. Inspect the st-metric elements in your Streamlit app. A metric is materialized as a div with the st-metric class, comprised of a label with st-metric label and a div with st-metric value. Select the st-metric parent first. Make its background color white, give it a round solid border with a little bit of shadow. Then move to the st-metric label and edit the size of the label a little. Finally, into the st-metric value, make the metric value a bigger, bolder green. Our metric cards are stunning now, but I do want to add a little red indicator on the low KPIs, a green one on the high KPIs, and a blue one on the neutral ones. Now remember, we consolidated metrics with a similar color border in an ST container. For example, the red metrics are included in a container with this low indicator invisible span CSS class. Well, if you could target every ST vertical block parent container with an invisible span of class low indicator, it would be easy to descend into every metric inside that selected container. Well, most recent web browser now supports the new has CSS selector. With the has selector, you can select any HTML element which contains a specific CSS collection. For example, select all ST vertical block divs that contain a direct div to ST-HTML to low indicator invisible class. You know, the class provided by the invisible span. Apply a red background color to see the parent container under the card turn red. Yeah, that's a way to validate your selections. Use a bright background. Now you can drill down into every ST-metric div inside the parent container. Apply a small left red border to the metric nested selection. Copy and paste this to run on the high indicator and bottom indicator, and again apply a border to those two. There's a guy playing flute outside. Can you hear it? I don't know. I'm not sure because I'm editing the audio, but yeah. Anyway, if you want a slower take on this coding speedrun to write at your own pace, I'll send it through email once I've recorded it. So join the mailing list in the description to catch the freebie once I release it. Okay. Let's finally move to the watchlist cards. Here's a reminder on the watch card. It comprises of a watchlist card span container, and each of the 4 different corners are columns with a dedicated invisible span element, followed by Streamlit widgets. Paste the previous long CSS selection and replace the CSS class names with the class name from the span element under the column you target. Give a bold green open sans to the P tag in the watchlist symbol name container and the watchlist price value container. Move the ticker symbol and change person to the right and make all of those a little smaller. The cards are a little tall, right? Well, if you inspect the P tags in there, I told you the HTML inspector is your best friend, you see they have a bottom margin by default. I would remove those two in CSS. Finally, I selected the container with the column, plot list span and chart and made all of those into a card with a round border and shadow. A bit of padding and margin edits and it looks better constrained now. If those CSS selections don't work anymore because you are on a newer Streamlit version than 1.34, always remember to bring out your HTML inspector and just check the location of the container, the span, and the element you are trying to style. Enjoy your final dashboard. If you learn HTML inspections and CSS, you can produce refined looking Streamlit apps like this one or this one. I actually find this is a fun and creative way to learn CSS selections and editing, and those skills are easy to transfer to alternative libraries with custom CSS arguments like Gradio or Solara. If you want another deep dive Streamlit project, you should check out this next video. It has OpenAI assistance. I'll see you around. Bye!